This is the additional sample assessment material for the 2020 specification for level 2 further maths. And this is paper 2, so you are allowed to use calculator. So let's start by having a look at question 1. So we need to multiply these matrices together to work out the values of A and B. So we've got 3 things multiplied together. It doesn't matter what order you multiply those in. So I'm just going to leave the 3 at the front for the minute and multiply these 2 together. Okay, so remember we do the first row multiplied by the first column. So 2 times 4 is 8, and then we add the next 2. So 1 times minus 3 is minus 3. So 8 minus 3 gives me 5. Okay, and then if we do the same on the bottom row, so this time we're doing minus 5 times 4, so minus 20. And then the other 2 elements give me 0, so just minus 20. So we know that's going to equal AB. And then I'll just multiply that matrix by 3, so it becomes 15 minus 60. So A is 15 and B is minus 60. Okay. You can actually use your calculator to multiply matrices together. So this one was pretty quick to do in your head, which is why I've done it in my head. However, on your calculator, if you go into your normal mode, you can see an option here, F3, it says matrices. So you just need to type in the size of the matrix. So my first one is a 2 by 2. Okay, so we can just type in 2, 1, minus 5, 0. Then press exit. For the second one, so remember it's number of rows first, so I've got 2 rows and 1 column, so it's 2 by 1. So 4 minus 3, press exit. Okay, so now if we go back into this mode, we're doing 3 times, and then you need to go to options. And then when you press F2, it's matrices, and F1, you need to say it's matrix A. And then times matrix B. Okay, and then you can see it gives you 15 minus 60. Okay, so definitely probably quite easy. It's very fiddly to multiply matrices, so I'd say if you can use your calculator, do use your calculator. Okay, and then you know you've definitely got a question right in the exam as well. All right, it's just not working for a minute. Right, so next one, again, I'm going to show you how to do it because obviously this could easily come up on the non-calculator, so I'm going to do it both ways. But as it's a non-calculator, sorry, as it's a calculator paper, I would just do it on your calculator. Okay, but for the practice, remember we're looking at the first row and the first column. So we go along the first row and down the first column. So 5 times 2 is 10. Minus 3 times minus 1 is 3. So I'm going to add those together. Okay, for this one here, I'm now on the second row and the first column. So 1 times 2 is 2. And then 2 and minus 1 is minus 2. For this one here, I'm on the first row but the second column. So 1 times minus 3 is minus 3. And then 2 times 5 is 10. Then here on the second row, second column, so 1 times minus 3 is minus 3, and 2 times 5 is 10. So we should get 13, 0, 7, 7. Okay. So again, just showing you how to do that in the calculator. You want to go into F3 matrix mode. So now I've got 2 by 2 for both of them. So this is 2 by 2. and I'm going to put in 5 minus 3, 1, 2. Press exit, and then to matrix B is also a 2 by 2. So we've got 2 minus 3 minus 1, 5. Press exit, exit again. So press options to get your matrix options up, F2 matrices. So I'm doing matrix A times matrix B. Okay, so I've got 13 minus 13, 0.7. So that shows I've done this one wrong here. My bad. Okay, so that shows how easy it is to make a mistake when you're doing it without a calculator. So this one is my first row, second column. So I'm going along my first row and then down my second column. So 5 times minus 3 is minus 15. And minus 3 times 5 is another minus 15. There you go. That calculator just shows you can find your own mistakes. So this is my answer. Okay. If you're using a different calculator, so the other option of calculator is Texas, the options are very similar. So you can still do the same functions on a Texas GDC as what you can on a Casio. So question 2, algebraic fractions. So I'm multiplying by the reciprocal because I'm dividing. So I'm going to flip that second fraction and change the division to multiplication. So now I can see I can cancel out the 5 and the 10. I can also cancel out one of my m's here with one of my m's here. So I'm left with 3m on the top. And I've got 2 times 2, which is 4 on the bottom. Okay, it's quite a standard question that you should see at GCSE as well. And then very similarly, adding fractions together. So think about the rules for adding fractions. When we add fractions, we find a common denominator. So I want a number that go 4x and 6y goes into. So they both, if we look at the numbers, go into 12. And then I'm going to need the x and the y as well. Okay, so your lowest common multiple, remember, isn't always just the multiplied together. You could have put it, lots of people would have put it over 24xy. That's fine, but you'll have some cancelling to do at the end. So always try and find the lowest common denominator. So for the first fraction, I'm going to multiply it by 3y. So I end up with 21y. For the second fraction, I need to multiply it by 2x. So I end up with 10x on top. So when I add them together, I've got 21y plus 10x all over 12xy. Number 3, so work out the positive value of x at which the rate of change of y with respect to x is 81. So as soon as you see this word rate of change of y, remember that means the gradient, so you're going to differentiate. So I'm going to start off, so even if you don't know what to do with the rest of the question, as soon as you see those keywords, differentiate, and then you've got some of the first marks. So bring the power to the front and take 1 off the power. So that gives me 5x to the 4 plus 1. Okay, so it's telling me the rate of change of y with respect to x, so in other words, dy dx, is equal to 81. So I've got to solve this. Okay, so if I subtract 1 from both sides, that gives me 5x to the 4. I can then divide by 5. Okay, and then it only wants a positive value of x. It's not interested in negative numbers. So if we take the 4th root of 16, then obviously it would be 2 plus or minus 2, but we're only interested in the positive value of x. So your answer is actually 2. Okay, bit of a trick on the calculator. If you go into graph mode, you can draw the graph. So x to the 5 plus x. Okay, and I'm just going to zoom auto so I can see kind of what it looks like. Okay, so remember the rate of change is the gradient. So looking for the point on that curve where the gradient equals 81. So it doesn't look like it's going to be 2. Let's have a look at what's going on. So if you go down to the second y graph, okay, and press options, you can get options for calculus. Okay, so if you go to calculus and then we want the differential, so what I'm going to do is I'm going to draw the graph of the gradient function. So I want the differential of the first graph, so y1, at all values of x, so x equals x. So what this red graph is, this red graph gives me the gradient at all these different points. Okay, so what you want to find is you want to find the point, the x value that gives you a gradient of 81. So if you go to GSolve and find the y value, make sure it's the red graph that's flashing because you've got 2 graphs here. So I want the point on the red graph where, sorry, I pressed the wrong one. GSolve. Oh. Try again. We want the x calculation, sorry. Okay, so you want the x calculation when the y value is 81. Okay, and you can see it gives you -2. If you press the arrow, it also gives you 2. Okay. So it was right. It didn't look very good on the graph because if you look at that axis, wow. Okay, the axis has got huge numbers on it. So look, 1 e to the 8 is standard form. So 1 times 10 to the 8. It's got really big numbers on the y-axis. Okay. So using your calculator to draw the gradient function is a really good idea on a calculator paper of checking that you've got your answers right. Right, another circle theorems question. So what have we got? A and C and B and D intersect at the point E. Gives you these values, and we've got to prove that y equals 90 minus 3 over 2x. Okay, so with a question like this, just think about your circle theorems and work out any angle that you can work out to see how they're linked, essentially. Okay, so because we have got this triangle ABE, we've got 2 angles in that triangle. So my natural instinct would be to work out what this angle here is. Okay, because you've just got angles in a triangle. So BAE is 180, take away x, take away 2x. So 180, take away 3x, because of angles in a triangle. Sorry, my technology is not working very well today. Okay. Now I know what that is. If we think about what links that to this expression that we've got here for y, okay, you've got the circle theorem, angles in the same segment, haven't you? So you know that EDC is going to be the same because of angles in the same segment. Okay, so therefore, because that angle was 2y has to be 180 take away 3x, So therefore 1y has to be 90 minus 3 over 2x. Okay, so quite a simple circle theorem question. Could get that at GCSE maths as well. Right, question 5. So it gives us a function. Which value of x cannot be in the domain of fx? Give an answer, circle your answer. Okay, so if we think about if we were going to work out the domain, obviously we'd draw a graph and think about where the asymptotes would be. Okay, so this is a relatively complicated graph, not something you would just automatically think of in your head. So x minus 3, 6x minus 5. Okay, so we can see, there we go. It is a reciprocal graph and it's got a horizontal and a vertical asymptote. Okay, so for the vertical asymptote, what are the options we've got? Okay, one thing you can do to sort of rule out some answers, we can see if we look at where the root is. Okay, the root is 3. So we know the vertical asymptotes before that, so that rules out that one. So it's definitely not 3. Okay, you can see straight away that it's bigger than 0. So it's definitely that one. So it's one of these two. Okay, so remember the asymptotes are the values the graph cannot take. So we cannot divide by 0. So therefore, 6x minus 5 is not allowed to equal 0. So if we solve that, then we can see that x is not allowed to be 5, 6. So that will actually be where that vertical asymptote is. Okay, quite hard to see on the graph. And obviously 5, 6 and 6 fifths are very close in value. Okay, but if you were doing this on a non-calculator paper, you would draw the graph and you would solve where your denominator equals 0. So the key point for this is the denominator. Really not working well today. Cannot equal 0. So if you didn't know that already, make sure that that point is clear in your head. So the next one, we've got gx is 32 minus 3x with domain minus 5 to 2. So we want to work out the range. Okay, so this time we definitely are going to have to draw a graph. Okay, so 32 minus 3x. I'm going to zoom auto so it looks a bit better. There we go. Okay, and it's a good idea to change your view window so it matches the domain. So we only want it between minus 5 and 2. So I'm going to go to my view window. I'm going to change my minimum x to minus 5 and my maximum to 2. So we can see what portion of the graph that we've got. Okay, so I would always sketch the graph. And put your endpoints on. So on the x-axis, it's going from minus 5 to 2. If we use G-solve again, we want the y calculation. I'm just going to find the y value at those endpoints. So when x is minus 5, my y value is 47. So on my graph here, it's at 47. And if we do the same thing again, the y calculation when x is 2, we get 26. Okay, so therefore your range is the set of y values your graph can take. So you can see if we read off any value on this graph, it would always have to lie between those endpoints. It would have to lie between 26 and 47. So your answer is, it can equal it as well because it can equal the 2 and the 5, minus 5. Okay, but it's going to be between 26 and 47. Okay, if you don't have a calculator, you just have to draw that graph by hand and obviously substitute those values in to find the endpoints. but I would definitely recommend getting a calculator if you don't have one. So we've got a weird F shape made of lots of different rectangles. The perimeter is 64. And we want to show what y is. So we need to get an expression for this perimeter. Okay, so I'm going to start with my vertical length. So here, 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 and here. Okay, so we've got y and another y is 2y and a 2x and a 2x. So we've got 2y, add 4x down that side. Okay, now if you squash that all together, so imagine pressing it inwards in this direction, it's going to give you the same, if you added them all up, as that length there. Okay, so actually, you've got two lots of that. If we now think about the horizontal lengths, we've got 3x and a 2x gives me 5x. What else have we got? We've got an x and another x gives me 2x. And another x down here. And then we've got everything, haven't we? So my perimeter is 4y, add 8x, add another 8x, so 4y, add 16x. Okay, and then it also tells you the perimeter is 64. So the expression we just worked out is equal to 64. So if we're trying to rearrange that to find y, 64 minus 16x is 4y. So if we divide through by 4, then we've got 16 minus 4x. Okay. This time we've got an expression for area. So we want to show that the area is that. So think about the easiest way to find area is probably, I'm going to chop it here. So you've got rectangle A, rectangle B, and rectangle C. So for rectangle A, remember the whole length was 2y plus 4x. So we want to multiply that by the x at the bottom. Okay, so this is the area of A. Okay, we just worked out an expression for y, so I'm going to substitute that in. So that will now be 32 minus 8x so we've got 32x minus 4x squared. Okay, now let's think about rectangle B. So rectangle B is just x multiplied by y. So 16x minus 4x squared. And then C is 2x multiplied by y. Okay, so if that's 2x multiplied by y, the last one was x multiplied by y, so I can just double it. Okay, and then the area altogether, so your total area is 32x minus 4x squared, add 16x minus 4x squared, add 32x minus 8x squared. So what have we got all together? We've got 32, another 32, and 16. I'm not going to rely on my brain for this. Okay, so we've got 80x. Then we've got minus 4x squared, minus 4x squared, minus 8x squared is minus 16x squared. Okay, and then that was what the show that was. So we know we've got that question right as well. So use calculus to work out the maximum value of A as x varies. So remember, as soon as you see the word maximum, you should be thinking about differentiating. So we want to differentiate A with respect to x. So that will give me 80 minus 32x. And remember, we're looking for the maximum. So on a graph, if you drew a graph of this, who knows what it would look like. But the maximum point, if you drew a tangent, here's my tangent, is always where the gradient is 0. So you're solving that your differential equals 0. So 32x equals 80, so x is 80 over 32, which is 2.5. Okay, again, you can use your calculator to double check this. So if we drew the graph of 80 minus 32x, no, sorry, your original graph, where's my original graph gone? Because obviously you might differentiate that wrong. So let's draw the original graph, 80x minus 16x squared. Okay, and just scroll across so you can see that turning point, and then G-solve max. Okay, so then you can see that x is 2.5 and the area would be 100. This question does say use calculus, so you wouldn't be able to just do that in the exam, write down 2.5. Okay, that would imply they do want to see some work in and that you understand the calculus behind that. Okay, but definitely use it to check. Answer. No, my answer isn't finished. I want the maximum value of A, sorry, not x. So this is my x coordinate. If we sub the x coordinate in, okay, so back into the original 80 times 2.5 minus 16 times 2.5 squared. Okay, but you can cheat a little bit because it will tell you in the graph that that is 100. So your maximum area is 100 when x equals 2.5. Okay, part C is rearranging to make D the subject. So we want to start off by removing this square root. So if you square both sides, then we've got rid of the square root. You can now multiply by 3D. And then any term that's got a d in it, you want to get on one side. So 3d c squared minus d is equal to 4. And that allows you to factorize out the d. And then obviously you can divide through by the bracket. So that's quite a standard rearranging question you could see at GCSE. Right, so for question 8, I'm asking you to factorise fully this expression. So we need to think about what there is in both terms. So I can see that if I look at the numbers, I can take a factor of 2 out. If I then look at the brackets, I can also take out a plus 3 to the power of 8. Okay. So I'm going to put square brackets because it can be confusing having brackets outside of brackets. So when you think about what do I need to multiply 2a plus 3 to the power of 8 by to get to a plus 3 to the power of 9. So I need another a plus 3 to the power of 1. So when I multiply these two together, I'm going to get a plus 3 to the power of 9. For my second term, I've already taken a 2 out the front. So to get the 8, I need a 4. And then I've already got a plus 3 to the power of 8. So that's all I need. I can then sort out what's in the square brackets. Right, pen's not working very well today. At all. Okay, so I'm going to collect together everything in my square brackets. I've got a plus 3, and then take away 4 gives me a take away 1. So that is your fully factorized expression. Let's have a look at part B. So part B is a little bit simpler because we're just dealing with x's rather than taking a whole bracket out. Okay, but you should be able to see you can take x to the 4 out of that, and then x to the 4, I need to multiply by x squared to get x to the 6, and then take away 9. Now this is worth 2 marks. So where it says factorise fully, that means normally you have to take out everything you possibly can. So for 2 marks, I'm not just going to have to take out a power of 4. So that should indicate to you there is something left that you can factorise. So x squared minus 9, we also need to factorise, and that is the difference of 2 squares. Okay, so remember, factorise fully normally means there's going to be more than one step in your factorising. Question 9. So we've got this quadrilateral that's made up of 2 triangles, and we want to work out the area of the whole quadrilateral, so A, B, C, D. So let's have a look and see what we've got. Okay, so I can obviously work out the area of this triangle ABC, because I've got the height and I've got the base. So I can do half height times base. Okay, and then ACD is obviously going to be a little bit trickier. So I'm going to have to use the other rule for the area of a triangle, so half AB sine C. But to use that, you need to have the angle and the 2 sides either side of it. So I'm trying to find out what this side here is. Okay, and obviously I can do that using the other triangle. So if I use Pythagoras on the other triangle, I've got 5 squared add 7 squared is AC squared. And that gives me the square root of 74 for AC. Okay, so I now know that this side here is the square root of 74. So the area of ACD is half, and then the 2 sides either side of it, so 11 and root 74, and then sine 38. So I'm just going to check my calculator is in degrees, which it is not. Okay, so we're in half, 11, root 74, and sine 38. Okay, so it gives me 29.1. Okay, and if I add those together, I've got my 35 over 2, add my last answer. So your total area gives you 46.6, so 3 significant figures. Okay, so relatively straightforward question. That is something you could get in GCSE maths as well. Question 10. quite simple. Wants us to work out the second derivative when x is -2. So we're going to differentiate once. So bring the power to the front, take 1 off the power. Okay, 6 over x, we have to think about powers. Remember, reciprocal is a negative power, so this is the same as 6x to the -1. So if we take the power to the front and take 1 off the power, we've now got plus 6x to the -2. To get my second derivative, I have got to differentiate again. So take the power to the front, take 1 off the power, take the power to the front, take 1 off the power. Okay, so you're just subbing in my x is -2. Okay. So 36 -2 squared -12 -2 to the power of -3. So that gives us 145.5. Okay, remember you can check that on your calculator because your calculator does do numerical differentiation for you. So in other words, if you're subbing in a number, it can't give you the algebraic expressions, but it can give you the numerical value. So if you go on your calculator to options and then calculus, and then you should see you've got a second derivative button. So we want the second derivative of, what was our original expression? 3x to the power of 4 minus 6 over x. Okay, and we want that when x is -2. Okay, and you can see that gives you 145.5. Okay, it is the rule in GCSE Further Maths that if you get the correct answer, you do get full marks. Okay, so in theory, I wouldn't recommend it because if you type in your calculator, then you've lost 4 marks. Okay, so I'd always show you're working and then sub your value in and use this to check. However, if you really forgot, for example, how to change 6 over x to 6x to the -1, and you knew you weren't going to get anywhere with this question, okay, as a last resort, just put down what the correct answer is from your calculator. Because it is allowed in the exam, so take advantage of that. Right, my technology is not working very well today, sorry. Let's try the next question. So we've got these two straight lines that make, what have we got? Triangle PQR. 3 straight lines. We want the x coordinate of R. Okay, so let's have a look at what is going on here. So it's giving you the intersection of these 2 lines here. We know they intersect at a right angle. And so with this sort of question, you just really want to find out anything you possibly can find out. So what we can do is we can find out what this point here is because we've got these 2 lines. So we could find out the intersection of P. Okay, we could also find out the equation of the line that goes through Q and R. And that would allow us to find the intersection of this one here. Okay, so going for the equation of the line is probably a good way to go. So if we've got the line 2y plus 3x equals 7. Okay, I know they're at right angles, so I want to find the gradient. So I'm going to rearrange this. So it's in the form y equals mx plus c. Okay, so I know the gradient of that first line is -3/2. So the gradient of the line through QR, because it's perpendicular, it's going to be the negative reciprocal. Okay, so I want to do the reciprocal and change the sign. So it's going to give me 2/3. Okay, so I've now got my gradient of my line. I know it goes through the point Q, so I can find the equation of the line using y minus y1 is mx minus x1. So my y coordinate is -1. My x coordinate is 3. So if I rearrange this, my pen is just not happy today. Okay, I now know the equation of the line is y equals 2/3 x minus 3. Okay, so the point R is where the equation of that line, so this is my y equals 2/3 x minus 3. So the point R is where that intersects with the line y equals 5. So my intersection will be 5 equals 2/3 x minus 3. So if we just solve that, that gives us x is 12. Okay, and we can check that on our calculator. So I'm just going to quickly draw the line. Two-thirds x minus 3, and the line y equals 5. Don't really need the other line. Okay, just make sure you can see the intersection on your page, otherwise it won't find it. So G solve intersect, and it tells you x is 12. So I know I've got that question right in the exam as well. Right, next question. Use the factor theorem to show that 2x minus 1 is a factor of this. Okay, so if 2x minus 1 is a factor, then the root would be when 2x minus 1 equals 0. Right, let's try that again. Pen is really not happy. Here we go. Okay, so because half would be the root, then if we subbed it in, we would expect to get 0. So that's the idea behind the factor theorem. Sum in the root and you get 0. So if we do f of half, okay, we should expect to see that that gives us 0. Okay, really quick way of subbing in, because I'm lazy and I don't want to sub in on the calculator. And you can do this if you haven't got a graphic calculator. You can do this on a normal calculator as well. There is a table function. Okay, so on the table function, you can type in your equation. So 4x cubed plus 28x squared plus 21x. Oh, don't want it like that. Try that again. Minus 18. Okay, so it'll give you a table of values and you can just overwrite. So if I type in a half, it will show me that it equals 0. So that's a really handy way and definitely less fiddly than sitting there typing all of that in on a calculator. Okay, so you do need to write at the end after you've shown that it equals 0, therefore 2x minus 1 is a factor. You do lose a mark if you don't write that last conclusion. Okay, so lots of people just show that it equals 0 and think, yep, I'm done. Okay, and then that means we want to fully factorise this next part. So because this is a factor, I know I can divide by it. So I'm going to do some algebraic long division. So when you're doing long division, we just look at the first term to start with, so 2x. So how many times does 2x go into 4x cubed? Or in other words, what do I have to multiply 2x by to get 4x cubed? So 2 times 2 gives me the 4, and x to the 1 times x squared gives me x cubed. I'm now going to multiply my expression by 2x squared to find my remainder. So I know that first term gives me 4x cubed. And then minus 1 times 2x squared gives me minus 2x squared. To get the remainder, you're then subtracting. So I'm doing 28x squared minus 2x squared. So that gives me 30x squared. And obviously the 4x cubed and 4x cubed goes away. So I can then bring down the next term, so 21x. So now I'm looking at how many times 2x goes into 30x squared. So 2 times 15 gives me the 30, and x times another x gives me the x squared. And then you're going to do the same process. So multiply 2x minus 1 by 15x. I've got 30x squared minus 15x. And subtracting them, so 21x minus 15x gives me 36x. Can then bring down the minus 18. And now I'm saying how many times does 2x go into 36x? And the answer is 18. So if I multiply those, unsurprisingly, I get a remainder of 0. So I know if I multiply 2x minus 1 by my answer I just got, so 2x squared plus 15x plus 18, that's going to be the same as the expression. Okay, but usually you'll also be able to factorise the other expressions. So this quadratic I can also factorise. Okay, so think about my factors of 18. What could I have? I've got 9 and 2, 9 and 2, 6 and 3. So 6 and 3 is looking good to me. Okay, so then that gives me 3x and 12x, which gives me my 15x. Okay, so then that is your final, pen wants to draw a line, that is your final answer. Okay, so do your algebraic long division, continue to factorise the answer, so don't just leave it as the top version. Question 13. Integers are made using some or all digits 1, 2, 3, 4, 5 and 6. Each integer made is greater than 50,000 and has no digits repeated. Okay, so if it's got to be greater than 50,000, so how many digits have we got? 1, 2, 3, 4, 5, 6. Okay, so let's think about if I'm using 1, 2, 3, 4, 5, 6. Okay, it does say some or all, so don't have to use all of them. That's quite interesting. Okay, so anything I use when I'm using all the digits is going to be greater than 50,000. Okay, so using all digits is an option. Okay, if I'm just using 5 of the digits, we need to think carefully about what it starts with. So if it started with a 1, so let's say we said 1, 2, 3, 4, and 5, that's not going to give me an answer that's greater than 50,000. So if it's 5 digits, it's going to have to start with a 5 or a 6. Okay? So if we are using all the digits, okay, let's think about our options. We've got 6 ways of picking the first number. Okay, and then we can't pick a 6 again, so we've only got 5 left. Then we've got 4, then we've got 3, then we've got 2, then we've got 1. So in other words, we have got 6 factorial ways of ordering those 6 numbers to use all the digits. Okay. For the 5 digits, it's a bit trickier. So we have to pick a 5 or a 6. So we've only got 2 ways of picking that first number. Okay. To pick the second number, it doesn't matter what number I pick. Okay. So I've taken one of the numbers out, obviously. So I've got another 5 ways left. And then the third digit, I've got 4. And then the fourth digit, I've got 3. And then the fifth digit, I've got 2. Okay. So we've got 2 times 5 times 4 times 3 times 2. So I've got 240 ways of picking a 5-digit number. Okay, or I've got the 6 factorial. So because I'm saying or, I'm going to add them together. So or 6 factorial. To get a factorial button, you have to go to options, probability, and it's there at the front. So I've got 960 ways. Okay, question 14. So we've got the coefficient of x squared in this expansion is 150. So we want 2 possible values of a. Okay, so if we are thinking about the power of 4, okay, the best thing to do sometimes is just expand the whole thing to see what the pattern is, okay, if that makes sense. So it's quite hard to pick out which one's going to give you a coefficient of x squared sometimes. Okay, if you can do that, well done. Okay, but for some people, they just prefer to do the whole expansion and then zone in on the x squared coefficient. So for this expansion, okay, we'll do 3 to the power of 4. Okay, and then my coefficient in Pascal's triangle is 4. So my power of 3's are going to decrease, and my power of ax is going to increase. For the next one, I've got 6. Powers of 3's are decreasing, ax is increasing. Okay. And then I'm not actually going to go any further than that because I can see straight away that this is going to give me my coefficient of x squared. So my next one is obviously giving me a coefficient of x cubed and then x to the power of 4. So this is the term that I'm interested in. So we've got 6 times 3 squared, which is 9. And then all of ax is squared, so it's a squared and then x squared. So we know this is going to give me 150. Okay. So a squared is going to be 150 divided by 6 times 9. So 25 over 9. Okay, and then there are two possible values. Obviously, because I'm square rooting, I can have the positive and negative root. It's going to be plus or minus, and then square root of 25 over 9, which is 5 over 3. Right, question 15 is a 3D trigonometry question. So it gives us this information which is on the diagram anyway. So we've got a triangular prism and we're trying to work out the angle FBC. So this angle in here. My pen has nearly given up forever. Okay. So any information we can work out about the triangle FBC would be very handy. Okay, so we can work out, what can we work out? So in this triangle EFB, we've got a side, we've got another side, we've got another side. Okay. So I'm going to call this theta. Okay, and then this side here is the side that we're interested in because this side here links both triangles. Okay, so I haven't really got enough information to work that out in triangle FBC, and I haven't really got enough information to work that out in EFB either. So not very useful. Okay, however, no, I have got enough information. So I'm going to draw a version. If we think about this rectangle EFBA, okay, so imagine we're looking at it like the plan view. It's going to be like that. So EFBA. Okay. So if we cut that down the middle, that is 70. And because it's a rectangle, that's obviously a right angle. So this is the side that we're interested in, FB, because that's the side that links the triangle that we're trying to find information out on. Okay, so that is just a right angle triangle. So this is the opposite side, and this is the adjacent side. So therefore, we know that tan 70 is the opposite side over the adjacent side, which is 12. So that opposite side, FB, is 12 tan 70. Okay. So I'm not going to work it out just yet. I'll work it out in a minute. Okay, so that means for our triangle, I'm going to draw that out in 2D as well. So FBC. Okay, FBC, so this tells you this side is 10. This is the angle we're trying to work out. And FB, we just worked out a minute ago, was 12 tan 70. So I've got my opposite side and my hypotenuse. So therefore, sine of the angle I'm trying to find out is the opposite side, which is 10, over the hypotenuse, which we just worked out, was 12 tan 70. Okay, so if I inverse sine that answer, I'm going to end up with my angle 17.7 to 3 sigma figures. Okay, so always draw your triangles out in 2D to make it really clear about whether they're right angled or whether they are non-right angled. Question 16, solving this equation. So 3 lots of hx is equal to h of 2x. So h of 2x, remember, means we're replacing the x with a 2x. So this x becomes a 2x, this x becomes a 2x. And this is the equation we're trying to solve. Okay, so we've got 15x minus 4. And then we've got 10x 2x minus 4. So we can expand the brackets on both sides. Okay, because I'm dealing with a quadratic, I'm going to put everything on one side. So I'm going to subtract 15x squared and add 60x. Okay, and then I can factorize. So take out 5x. So x is 0 or x is minus 4. Okay, remember you can also use graphs to solve equations. So rather than doing all that algebraic work, okay, you could draw the graph of this first side. So you don't even have to simplify it. So 3 times 5x, x minus 4 was one side. And then the other side was just replacing the two x's. So 5 times 2x times 2x minus 4. Okay, so if you draw both of those and then see where they intersect, you can see it's at minus 4 and 0. Okay, so I know I've got it right. Okay, number 17. So this is where you wouldn't get away with just doing things in your graph because it says you must show your working. Okay, so we definitely need to do this one algebraically, but again, use graphs and graph work to check your answers. So we have got simultaneous equations that we want to solve. Okay, so remember when you've got simultaneous equations where you've got one that is got quadratics in it, use the linear one and sub it into the quadratic one. So I'm going to rearrange this linear one, so it's x is 2 plus y. And now I'm going to replace all my x's with 2 plus y. Okay, and then expand all the brackets. Keep expanding brackets. Okay, and then collect all your like terms together. So we've got 15y squared minus 7y squared. So I've got 8y squared. Got 40y, 50y. And then I've got 40 and 23. Okay, so this is the quadratic we're solving. Okay, I'm going to solve this one on my calculator. So go to equation, go to polynomial, and you can just type in your A, B, and C rather than use the quadratic formula. So 58, 50, and 63. Okay, so this one does factorise because it's giving me exact answers. So you can definitely have a go at factorising it. But as it's a calculator paper, why would we want to? So y is minus 9 over 2. And minus 7 over 4. Okay, so they're the two y values that you've got. Remember, you also have got the x values that correspond to that. So x was 2 plus y. Okay, so we just want to add 2 to both those answers. So we've got minus 5 over 2. Okay, so they are your 4 answers. Again, we can check on our calculator that these are the answers that we want. Okay, on your calculator, this one is a bit tricky to do on your calculator, to be fair, because you need to make y the subject. Okay, so to be honest, it's probably longer to check out your calculator because we need to rearrange this one to find y. Okay, and to do that, we'd have to complete the square. So it's going to take a long time, so we're not going to do that. However, if it's a more simple quadratic, definitely draw both graphs and see where they cross. Okay. Number 18. So we've got y equals a times b to the power of x, and it gives us 2 points that are on the curve. We want to work out the values of a and b. Okay, now this is really easy peasy to do on your calculator, but again, I'm going to show you both ways. Okay, so we're going to do it by substituting in. So remember, when it gives you a set of coordinates, it gives you an x value and a y value. So you can just sub those into the curve. So y is minus 4. And our equation is a times b to the power of x, and x is minus 1. Okay, so we've got an equation there that says minus 4 is a, b to the minus 1. I'm just going to simplify that slightly. So because it's a negative power, that's the same as a reciprocal, so it's a over b is minus 4. Okay, my next one is minus 4 over 3 is a times b to the minus 2. So again, I'm going to simplify it to make it minus 4 over 3 is a over b squared. Okay, so you have simultaneous equations. You want to sub one into the other one. Okay, so I'm going to rearrange this one. So it's a is minus 4b. I can then sub that in to here. Okay, so I'm going to replace the A with minus 4b. Okay, one of my b's is going to cancel out, so this b on the top cancels out with this b down here. And then I can cross multiply. So minus 4b is minus 12. So b must equal 3. And a is minus 4b, so it's minus 4 times 3, which is minus 12. Okay, so they're your values of a and b. Now on your calculator, let's have a look. Okay, the first thing you can do to check it is you can draw the graph. So we said A was minus 12 and B was 3. Okay, so let's have a look. It looks the same sort of shape. Okay, and we can check quite quickly. So if we go G-solve and find the y calculation when x is minus 1, we should hopefully get minus 4. Correct. If we do the same thing for the other point, make sure the other one is on there. So when x is minus 2, hopefully we get minus 4/3, which is minus 1/3. Correct. So I know I've done it right. Okay. The other thing you can do, so if you go to statistics mode, and just delete what's on there, you can substitute in the points. So list 1 is your x value, so minus 1 and minus 2. And then your y coordinates are minus 4 and minus 4/3. Okay, now what you can do is you can draw the graph and then calculate the line. Okay, so if you scroll along the different types of graphs that you can work out, okay, one of them is exponential. Okay, so you can see it's got the a, b to the power of x. Non-real error. Now, I don't think it likes negative numbers for some reason. Okay, however, no, it doesn't like it. For some reason it doesn't like negative numbers, which is probably why they've given you one with negative numbers, so you can't just cheat and put that in your graph. Okay, but for lots of these questions, so if you didn't have negative numbers, remember you could just put in to that regression line and it will give you the equation of the graph. So it's always worth giving that a try. Okay, but obviously you need to know the method because A, it could come up on a non-calculated paper, and B, it's best to show your methods and use your calculator to check so you still get full working marks. Right, question 19. Which looks quite scary. So it's just a quadratic identity, so it's saying simplify this expression, essentially. So let's have a look at what is going on. So what I would probably do, and with this you can try things. Sometimes you're going to try something with an identity, it's not going to work. Okay, I'm going to leave the sine cubed x there at the front. Okay, and then for my second two terms, I'm going to factorize out cos x. Okay, you'll see why in a minute. So if I take cos x out, I've got 1 minus cos squared x. So hopefully you can see why I chose to do that. So I clocked, if I factorize out cos x, then I'd get 1 minus cos squared, and that is obviously something I can replace with sine squared. Okay, so remember, sine squared add cos squared is 1. So if you can rearrange to get 1 minus sine squared or 1 minus cos squared, you can always replace it with the other trigonometric ratio. So I'm going to replace this bracket with sine squared. Now you're probably thinking it doesn't help much. Okay, but bear with me. So let's try again then. So if I now look at my numerator, I can take out a factor now of sine squared. So I can take sine squared out. If my pen will let me. Okay, so I'm left with sine x for the first term and cos x for the second term. Okay, now conveniently that's also on the bottom, so that means I can divide through by that bracket and I'm just left with sine squared x. So as far as identities go, that is quite a tricky one because you have to really spot that beginning part with this last two terms on the numerator. Okay, but it is a question 19, it is the very end of the paper, so obviously it's going to be your grade 9 further maths GCSE question. It's going to be tricky. Okay, and that is the end of this paper. Hope you enjoyed.